Welcome back to my channel. So today we're going to discuss about Kubernetes, which is somehow an advancement of. So we will going to be discussing how the Kubernetes works, and we will be also going to run some commands in order to install Kubernetes. This is completely the skill setting experiment we are going to learn. So what is Kubernetes? It is also known as KIS, which is an open source automating development, scaling and management of containerized applications. Now, what do we do in Docker? Basically, we are creating some images. Later, we are converting those images into containers in the build process. And finally, we are deploying those containers in order to ensure the project is deployed successfully. That is the only thing we are doing. But coming to Kubernetes, this one automates the deployment. Okay, it is also happening somehow in Docker. Scaling means Kubernetes manages how the scale of the project should exist. And obviously, these containerized applications sometimes might not work properly when they are deleted or overridden. So Kubernetes takes care of this. So that is the main advantage in the Kubernetes. So we can see Docker's disadvantage is Kubernetes advantage. In Docker, additional tools, whatever we are wanting to add, they should be added in the manual scale. But automatically, here HPA is some particular thing that exists in the Kubernetes. Automatically adjust the replicas based on demand. So whenever this particular demand is existing on that particular content or item, then only the Kubernetes will trigger or will fetch that particular resource. And Docker is single host focus. That is not an advantage because when multiple nodes are working, containers can be managed across distributed clusters. So that became an advantage of Kubernetes. As well as when the project or the containers, whatever are existing, when they are deleted or when they are not in use, they will run automatically. That is not good, it is a vulnerability. So there is no self-healing capability. So whenever the restart process or the overriding process failed, containers, what they should do is they should redistribute the workflow entire project. On the entire project, they have to redistribute the workflow. But that is the disadvantage. It is not happening in Docker. That's why it is an advantage of Kubernetes. Then, non-native load balance. Basically, load balancing in the sense, uh, like managing the resources kind of thing. So, here, providing load balancing and traffic distribution is an advantage in Kubernetes. Because, why it is an advantage? Because there are multiple nodes working. It is not like Docker where only single host is focused. Here it is multiple nodes, so automatically the load will also be distributed. So the traffic will be distributed and also provides the internal load balance. And here the cluster-wide networking is applied. So what is the situation is mostly the flat networking model with advanced service discovery is available in Kubernetes. Guys, what is the use of this? See, for suppose if you have a full stack project, for suppose Docker maximum it can contain 2 to 3 containers in a single network. The network will be changed. But in the Kubernetes, the advantage is advanced service is available such that all the kinds of containers, whatever they may use, they can be in a same single network. That is the advantage. Because basic networking with host-centric approach is being done in the Docker. Host-centric in the sense, only the local host is affected. But in the Kubernetes, based on clusters, we divide the hosts and we will perform the operations manually. Like, sorry, not manually, automatically. This is highly available. And here, redundancy is there. Why redundancy? See, like, why to have a copy of key or a spare key, etc. For safe, for safe side. The same way. But here in the Docker, there is no redundancy. Duplication of containers is not accepted. So that's why whenever the new container we are creating with the same name, it will override the existing container. So that is the disadvantage. If we have a safe site, we can try two different approaches for two different projects. That is not there in Docker. So that's why Kubernetes has that advantage. And storage is also limited. If you see here in the Docker, uh, wait a minute. Oh, not good. Right? Yeah. Here, if you observe carefully, wait a minute. Here in the Docker, you can see whenever the containers or images are running, you can see the limited amount of storage exists. So that is what limited storage is. So there are many things. Most effective benefits are container orchestration. What is that means? Multiple containers across multiple machines can be deployed, managed, and monitored automatically. High availability, scalability, efficient resources. Here it is again one step ahead of on Docker. Schedules containers to best use CPU memory and infrastructure. You can recollect the concept of operating system where the particular process is unable to utilize the CPU entirely or effectively. There, some kind of thing will come that is the to do for you. You can అంటే నాకు గుర్తు రావట్లేదు సో మీకు to do ఇచ్చాను కమెంట్ సెక్షన్ లో ప్యాక్ చేసుకోండి నెక్స్ట్ ఆటోమేటెడ్ అప్డేట్స్ సి డాకర్ లో మనకి వెన్ ఎవర్ వి వాంట్ సమ్ అప్డేట్స్ వి గెట్ నోటిఫికేషన్ 1 మంత్ వచ్చింది అలా 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 1 మంత్ 2 మంత్స్ 3 మంత్స్ అలా అప్డేట్ చేయకుండా ఉంటే అయిపోద్ది డాకర్ వర్క్ అవ్వదు బట్ ఇది అలా కాదు మినిమల్ రోల్ బ్యాక్స్ డౌన్ టైమ్ తో రోలింగ్ అప్డేట్స్ అండ్ రోల్ బ్యాక్స్ రెండు మినిమల్ డౌన్ టైమ్ లో జరుగుతూ ఉంటాయి దట్ ఈస్ ఆటోమేటెడ్ అప్డేట్స్ సెక్యూర్ కాన్ఫిగరేషన్ మేనేజెస్ సీక్రెట్స్ అండ్ ఎన్వైరన్మెంట్ configs safely. Then now we have a few terminologies in Kubernetes. So first one is cluster. Complete Kubernetes environment that you manage, made up of many machines. Machines in the sense we can think of EC2 instance in Amazon Linux, the AWS environment లో EC2 instance అనుకోవచ్చు లేదనుకుంటే Docker container అనుకోవచ్చు. So we can take an example of these two things, any of these two things, and then we come back, and then come with the node. It is each machine inside a cluster is a node. Cluster is a collection of machines. Each of that machine is called as a node, where workloads run actually. Workloads run actually. And what is the pod? In that each particular node, we will have the smallest deployable unit. Not only node in the container, means a cluster, whatever it is. These pods live on nodes, so these automatically become a part of a container. So these are subjected to be the smallest deployable units that hold our running containers. And then the deployment. What is this deployment? The deployment scale can be enlarged or compressed, performing zero downtime updates or rollbackings or updates, whatever the things. Then the service, exposing the apps internally or externally as well as balancing the traffic. So virus deployment and service are like somehow these terms are like very well known for us, but still we will learn many things. And then the control panel. This is like a brain of the Kubernetes. Control plan, sorry, control plane. Control panel is brain of our computer. Whatever applications we are unable to remove, we can remove from there. So that is the brain of the computer. Well, like that button. But here it is control plane. That is the central brain manages the clusters. So you can come across an hierarchy, right? Just you can, if you can imagine, please try to imagine it. Being superior at the control plane, down to that there are clusters, down to that there are nodes. On the nodes there are, like, just assume or imagine dot-like structures called pods. So it is like a three-tier architecture or hierarchy. Yes, it is good. So this is about Kubernetes. So we will go through some comments. I hope you are able to see. Wait a minute. So guys, this is the notes I had written in the class during the class. And now what we need to do now? You have to open the Docker, click on Kubernetes, and on the Kubernetes, clustering default, like this. Then already almost typing. So here, Kubernetes, enable Kubernetes, కొడితే వచ్చేస్తుంది. So this will work. No issues. So now the biggest task for you is we have this particular command prompt. So guys, these are the commands that we need to run. What does this do? Like, we will discuss what all these do. The first one is kubectl, that is kube control. CTL in the sense control. So system CTL అంటే సిస్టమ్ కంట్రోల్ అలాగా. kubectl అంటే kubernetes control సంబంధించిన కమాండ్ అన్నమాట. ఆ డొమైన్ కి సంబంధించి. వాట్ వీఆర్ వాంటింగ్ ఈజ్ కంటెక్స్. సో ఎప్పుడు కూడా మనం కాన్ఫిగ్ మోడ్ లో చేస్తాం కంటెక్స్ అన్ని. సో అది ఏం చేస్తుంది కమాండ్ అంటే, దిస్ లిస్ట్ ఆల్ అవైలబుల్ క్లస్టర్స్ యాజ్ కంటెక్స్ అండ్ దెన్ kubectl config use context అని ఉంది. So we will use that particular context. We are specifying Docker desktop as the context name. So that is using the Docker desktop as the application. Then kubectl get nodes. What do we discuss in the nodes? That nodes are the smallest deployable, machine. A machine inside a cluster is a node. Next, get pods అని ఉంటుందండి. This is get pods. What does this get pods do is, this get pods basically returns the pods for the system control unit. Next, cluster info, whenever we are cluster info in the sense you can assume it as a present working directory in Linux. Cluster info in the sense ls command and goch, the kind of working like that. Now we are creating the nginx server deployment. So we are as we took the Docker, we are creating an image, the name nginx. Basically, this Kubernetes, what does this have? Load balancing. Built-in load balancing. So because of that, we use load balancer in the type of nginx to expose the deployment that is being happened in the port 8080 in the local machine and the target port of 80. So one after the other, if you run these commands, this is the kind of output you may get. So you can see my cursor carefully. kubectl config get context means it gives present working clusters, whatever we have. Then use context Docker desktop means we are switching to this particular context. Then here get nodes in the sense we will get whether the status of the node is ready or not, whatever the available nodes that we have. Later, we are running kubectl cluster info that provides running at this particular internal port number in the secured web browser. This also gives this particular link. So next, kubectl get pods in the sense As there are no like machines inside the cluster, we didn't have any machines. It returns no resources found in the default namespace. Then kubectl create deployment nginx hyphen hyphen image equals to nginx is we are creating an nginx image. So then kubectl expose the deployment nginx hyphen hyphen type equals load balancer hyphen hyphen port equals 8080 means where we are given the target port as 80. This particular what we have created is exposed here in the name of service. So that is about the things. And final output, you will be having this. If you do have Jenkins in the same 8080 port number, I have an alternative for this. If you have Jenkins, బుద్ధులు మాట్లాడు Jenkins in 8080 port number, then what do we do is Windows plus R, capital or small, whatever, equals to what do we give is services.msc. There, what do we do? Check for Jenkins. Stop the service. ఇది మనం చేసిందే. మన ప్రీవియస్ వీడియోస్ మీరు ఒకసారి చూస్తే మీకు అర్థమైపోతుందండి ఎలా చేయాలనేది. సో దట్ ఈస్ అబౌట్ ద 13th ఎక్స్పెరిమెంట్ ఇన్ ద స్కిల్ సెషన్స్. సో అంతే. థ్యాంక్ యూ. థ్యాంక్స్ ఫర్ వాచింగ్. బై బాయ్ 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 బాయ్.